Number 4, this is applications of differential equations to Kirchhoff's law on circuits. The basic laws governing the flow of electric current in a circuit or a network is presented in the next few slides. So basically this one. Let's take the first definition. That's KCL. That's the Kirchhoff's current law. So the current entering any junction is equal to the current leaving the same junction. So input minus output equals 0, or basically input equals output. That's why you have here I2 plus I3 should be equal to I1 plus I4. So this is the Kirchhoff's current law. So for Kirchhoff's voltage law, the sum of all the voltages around the loop is equal to 0. If this is your circuit, and then this is the potential difference across the whole circuit, V1 plus V2 plus V3 is equal to V4, or basically V1 plus V2 plus V3 minus V4 is equal to 0. So this is just the internal resistance. So a circuit is treated as a network containing only one closed path. So that one, for a circuit, the Kirchhoff's current law indicates that the current is the same throughout the circuit. And then to apply the Kirchhoff's voltage law, it is necessary to know the contributions of each of the elements. So what are those elements? This one, the total voltage is ET, the electromotive force. So ang units niyan is volts. This one, L is the inductor, R is the resistor, and C is the capacitor. So sometimes this is what you call an LRC. According to the definition here, know the contributions of each. So that means each of them may ginagamit na voltage. So how do we attribute what voltage to what element? First, let's take the, sabihin natin, capacitor. Okay, for the capacitor, capacitance C, the unit is farads. The voltage drop across the capacitor is Q over C.
Sir, is that the charge?
Yes, the charge capacitor. Therefore, I can say here that the E attributed to the capacitor, or pwede nating sabihin V attributed to the capacitor, is Q over C. For the inductor, the inductance L, the unit is Henry. Plural is Henrys. So voltage drop across is L di over dt. So here, the E due to the inductor, or sometimes V due to the inductor, is L di over dt, where I is the current, L is the inductor, the inductance. So here, lastly, the E due to the resistor, or V due to the resistor, is IR. So basically, ito Ohm's law, the other one's the Coulomb's law. So if I ask you, what is the total voltage across? So I can see here that the total voltage across is basically the voltage due to the capacitor, due to the resistor, and due to the inductor. For a series circuit containing only an inductor and resistor, so it's LR circuit, the Kirchhoff's second law states that the sum of the voltage drop across the inductor and the voltage drop across the resistor is the same as the impressed voltage on the circuit. So how does this work? Earlier, I showed you an LRC circuit where it's complete, wherein the total voltage drop is EC plus ER plus EL. So in this case, it's simply LNR. So that means the formula would be reduced to this. ET is basically EC plus ER plus EL, wherein C is equal to Q over C, right? And then this one is I R. This one is L di over dt. That's the E as a function of time. If the capacitor is not present, just cross that out. You will be left with IR plus L di over dt is equal to the impressed voltage. If you have naman a circuit that is an RC, meaning there's no inductor present, the Kirchhoff's second law states that the sum of the voltage drop across the resistor and the voltage drop across the capacitor is the same as the impressed voltage. So that means in total voltage more the voltage across, diba, ET, EC, ER, EL, wala naman yung inductor. So EC is equal to Q over C plus IR. This is your ET. You have to take note that the current is the change of charge with respect to time. Okay, so let's try this. A 10 ohm resistor and a 5 Henry inductor are connected to a 50 volt source at time equals t0. Express the current as a function of time, and then what happens to the value of I as time goes on indefinitely. So you have a voltage, inductor, charge resistor. Okay, so the inductor L has values of 5 Henry, and then the resistor has a value of 10 ohms. So the E, 50 volts. What else is given? You know that you're asked to solve for I as a function of t, and then what happens to I as t approaches infinity. You should know that when time is equal to 0, the current coursing through the circuit or passing through the circuit, dapat wala rin kasi hindi ka pa nagsa-start. You understand? Okay, so let's begin with the working equation. E as a function of t is E, C, plus E, R, plus E, L. You know that EC should be 0. So that means this one, that's I, R, plus di over dt is equal to E. Now, what are the constants that we can plug in? Is 50 all the time 50? Yes. Is 5 Henry all the time 5 Henry? Yes.
Yes.
Is the 10 ohms all the time 10 ohms? Yes. So for the time when current is 10 amperes, yun nagbabago kasi 10 amperes is only at a particular time. But then the inductor would have a constant value. The resistor would have a constant value. Okay. So this one, I times 10 plus 5 di over dt. So it looks ugly. Maybe we can simplify. Di over dt plus 2I is equal to 10. How does it look like? What's the form?
Linear, sir.
So it is linear in I. So if it's linear in I, you have to have a P, you have the Q, and the integrating factor, e to the integral of P something. Now, P of what? Q of what?
2,
2. What about the Q?
10,
10.
10. Therefore, this is e to the integral of 2 dt. So e to the 2t. So our working equation would be
I.
Therefore, I e to the 2t integral of 10 e to the 2t dt. So upon integration, this one, di ba 1/2 dapat? Plus C. Therefore, 5e to the 2t plus C, 1e to the 2t. So this is your general solution because it still has a constant. Take note, guys, the C here is not capacitance. It's just the constant of integration. When time equals 0, the current flowing through it should be 0. So that means 0 times e to the 0, 5e to the 0 plus C. So C is negative 5. Therefore, I e to the 2t is equal to 5e to the 2t minus 5. And then if you want this I as a function of time, I can factor out the 5 later on. So ito minus 5e to the negative 2t or 5, 1 minus e to the negative 2t parenthesis. So that's it. So this one here is your final answer. That is your letter A, I as a function of t.
Sir, is it always linear?
Yes, the form will be linear. So let's try letter B. You're asked, what is the current as time goes on indefinitely? So that means when time approaches positive infinity, let's just plug it in. What would be the value? I 5, 1 minus e to the negative infinity, 0. So 5 amperes is your current. So that means when time goes on and on and on and on, eventually the current flowing through the system is 5 amperes. Example number 2, a decaying EMF which has a value of 200e to the negative 5t is connected in series with a 20 ohm resistor and a 0.01 farad capacitor. Assuming Q is equal to 0 and T equals 0, find the charge and current at any time. So meaning, you're asked to solve for Q as a function of time and probably I as a function of time. Show that the charge reaches a maximum, calculate it, and find when it is reached. What you have now is the resistor and a capacitor. Okay. So here E equals 200 e to the negative 5t. The C has a value of 0.01 farad. The resistor 20 ohm. All right. Q0 time equals 0. So basically, when time is 0, the Q is 0. What else? Find the charge at any time t. Okay. So, letter A, T, letter B, Q, when it's reached. So Q max. Here ask Q max. When is the Q max? And what's the value? All right. So here E is ER plus EC. For ER, that's IR. For EC, that's Q over C, a function of time. Note that the current is what?
The differential of charge with respect to time.
dq over dt. So, E as a function of t is r dq over dt plus q over c. Now, let's plug in muna the values that we can plug in. Yung et, decaying siya. So, nagbabago. Hindi siya constant. Yung r natin is constant. It's 20 dq over dt. And then lastly, yung c natin is constant. So, q over 0.01. So, let's rewrite this. So, 5q is equal to 10 e to the negative 5. Linear in?
Q.
Linear in q. Since it's linear in q, p of t, q of t e to the integral of pt dt. So with that, okay, can you help me? What's p?
5, sir.
5. What is q?
Yung 10 e raised to negative 5t.
Tama. What's e to the pt dt? So e to the
5t.
5t. Okay, so since it's linear in q, q e to the 5t is equal to the integral of 10 e to the negative 5t e to the 5t dt. So q e to the 5t integral of 10 dt, because e to the negative 5t and e to the 5t cancel out each other, right? So this one just gives us q e to the 5t is equal to 10t plus c. So this one is your general solution. How do I solve for c again? When time equals 0, q is equal to 0. Help me plug it in. So 0, e to the 0, 10, 0 plus c. Therefore, I can say c is 0. So, q e to the 5t is equal to 10t. 6. Okay. So that means this is your q as a function of time. This one, or you can isolate it. You can make it 10t e to the negative 5t. Okay. Note that q is maximum when dq over dt is 0. Diba typically maximum or minimum? In our case, it's maximum when dq over dt is 0. So from letter A, q e to the 5t is equal to 10. Let's apply the first derivative. Copy the first derivative of the second plus copy the second derivative of the first is equal to 10.
Yes, boss, sir.
And isn't it that you want to optimize? Therefore, if that is equal to 0, That means 5q e to the 5t is equal to 10, or yung q e to the 5t is equal to 2. This is equation A. This is equation 2. Plug in 2 in A. Okay, what happens if I plug that in? 2.
10t is equal to 2, sir.
So that means you will reach the maximum charge when time is 1/5 of a second, or 0.2 second, right? And then the next question is, what is the value? How do you get the value? Plug in t equals 1/5 second in A. So q e to the 5 times 1/5 is equal to 10 times 1/5. So QE is equal to 2. 2 over E coulombs. So let's try this one. An electric circuit contains 8 ohm resistor in series with an inductor at 0.5 Henry and a battery of E volts constant. At time equals 0, the current is 0, and then find E if the maximum current flowing in the circuit is 8 amperes. Okay, 8 ohm resistor, 0.5 Henry capacitor. Resistor, and then inductor siya, no, Henry. Okay, so here, what is the E? Volts. What about the resistor? 8 ohms. The inductor is 0.5 Henry. At time equals 0, current is 0. So ito yung initial value ng current. Find E if the maximum current flowing in the circuit is 8 amperes. So let's have the equation. E as a function of time is E due to R plus E due to L. What?
IR, sir.
IR. What about E due to L?
L times the differential of I with respect to time.
Okay. Thank you. So with this, let's plug in. Ito, E na lang to. So 8I plus the L is 0.5 di over dt. So let's rearrange. 16I to E. Tama? So this one is linear in I. What is the E if I max is equal to 8A? When will this happen? I max. When?
When di over dt equals 0.
Di ba ito? From here, 0 plus, kailan doon nangyayari to? What's the I max?
8 amperes.
Therefore,
E equals 64 volts.
let's say I have another question. B. What is I as a function of time? P of t, Q of t, e to the integral of pt dt. Ito on the assumption lang na you have another question. 16 to e to the 16t. Therefore, I e to the 16t integral of 2e to the 16t dt. One over 8 e to the 16t plus c. Okay. Therefore, c is actually equal to negative 1/8 capital E, right? So, wala na akong space. I e to the 16t equals 1 over 8 e to the 16t minus 1 over 8 e. Right? So let's just factor.